In this episode, we move from deciding that an artificial intelligence, AI, system can be deployed to the harder question of how an organization keeps that deployment under control once it becomes part of real work. For a beginner, this is where governance stops sounding like a policy document and starts looking like a set of practical controls that shape daily behavior, data handling, decision-making, and accountability. A system may be technically ready, contractually approved, and even welcomed by the business, yet still become risky if nobody has built clear controls around the data it touches, the risks it creates, the issues it may surface, and the people expected to use it responsibly. That is why this topic matters so much. Governance at deployment is not only about launch approval. It is about building the operating discipline that keeps the system useful, bounded, and defensible once it begins influencing real workflows, real judgments, and sometimes real outcomes for other human beings. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful way to understand governance controls is to think of them as the structures that turn broad good intentions into repeatable behavior. Many organizations say they care about safety, privacy, fairness, and accountability, but those values do not protect anyone by themselves unless they are translated into practical rules, review steps, monitoring habits, and trained behavior that people can actually follow under pressure. Controls do that translation work. They define how data should move, how risks should be tracked, how concerns should be raised, and how users should be prepared before they rely on the system. For a beginner, this is a major shift in perspective because governance is often imagined as something abstract that lives above the work. In reality, good governance is woven into the work. It appears in who can access what must be documented, who decides when a risk is accepted, how a concern gets escalated, and whether users are taught to challenge the system rather than quietly defer to it. Data is one of the first places where deployment controls need to become concrete, because a deployed AI system does not operate on ideas alone. It operates on information that moves through pipelines, interfaces, storage locations, prompts, logs, and connected business processes. That means an organization should understand what data the system receives, where that data comes from, what quality it has, how sensitive it is, who is allowed to use it, and whether the data being used in production truly matches the assumptions made during evaluation. Good data controls begin with basic discipline around purpose. If the system was approved to support one specific workflow, teams should not casually feed it unrelated information, sensitive material that was never part of the review, or large collections of data simply because access happens to be technically possible. For a beginner, this matters because many AI governance failures begin with uncontrolled data expansion. The system's technical power grows faster than the organization's discipline around where it should and should not be allowed to look. Data controls also need to address quality, because poor information can turn even a promising system into a source of weak judgment or avoidable harm. A deployment may appear stable in testing and then degrade in practice because live data is incomplete, inconsistent, outdated, noisy, or shaped by processes that nobody reviewed carefully before launch. That is why organizations should not only ask whether the system can access data, but whether the data is reliable enough to support the role the system is being asked to play. Good governance may therefore include validation checks, access restrictions, retention limits, review of upstream data sources, and clear responsibility for resolving data problems when they appear. For a beginner, one of the clearest lessons in AI governance is that data is not a passive input. It is part of the operating environment. If the environment is weak, the deployment becomes weak, and no amount of optimism about the model itself can fully compensate for that weakness once the system is used in everyday conditions. Another important data control is minimization, which means the organization should avoid giving the deployed system more information than it actually needs to perform its approved function. This matters for privacy, security, and governance all at once. When unnecessary data enters the workflow, the organization increases its exposure without clearly increasing value. and it often becomes harder later to explain why that information was needed in the first place. Minimization supports discipline by forcing teams to ask what the system truly requires, what can be withheld, what should be masked, and what should remain outside the AI process entirely. For a beginner, this principle is useful because it counters a very common but risky instinct in technical projects, which is to believe that more data must always make the system smarter. Sometimes more data simply makes the system harder to govern, harder to defend, and more costly to monitor if something goes wrong. Good deployment controls therefore keep the data footprint proportionate to the use case rather than allowing the deployment to grow in silent and unnecessary ways. Risk controls are the next major layer, and they matter because no deployment is free of uncertainty. The organization must decide what kinds of risk exist, how serious they are, who owns them, and what actions are required before those risks can be accepted or reduced. A strong deployment process does not treat risk as a vague feeling or a background caution. It records the important risks in a form people can review, challenge, and revisit over time. That may include operational risk, privacy risk, security risk, fairness risk, legal exposure, reputational harm, over-reliance by users, or failure in unusual conditions. For a beginner, the essential point is that risk control is not about proving a system is perfect. It is about making sure uncertainty is visible, named, owned, and matched to real decisions. When nobody clearly owns the risks created by a deployment, the system may continue operating under assumptions that no one is actually prepared to defend once performance drops, complaints rise, or an incident attracts serious attention from leadership or the outside world. Good risk controls also define thresholds and responses. It is not enough to say a deployment should be monitored for concern. The organization should know what kinds of changes or warning signs would trigger closer review, stronger human oversight, a pause in deployment, or even a rollback. If the system begins making more errors, handling certain cases poorly, showing signs of drift, or producing outputs that staff increasingly struggle to trust, there should be a path from that observation to a governance decision. Beginners should understand that risk becomes manageable only when it is connected to action. A risk register that nobody consults, or a dashboard that nobody is authorized to act on, does not give the organization much real protection. The value of a risk control lies in linking awareness to responsibility. Someone must know when the signal matters, who can decide what happens next, and how the organization will document the reasoning behind continuing, narrowing, or interrupting the deployment under changing conditions. Issue management is closely related to risk, but it serves a different purpose. Risk controls focus on what could go wrong and how the organization will prepare for or reduce that possibility. Issue controls focus on what happens when something actually seems wrong, unclear, or concerning during operation. An issue may be a repeated user complaint, a confusing output pattern, an access concern, a quality decline, an unexpected behavior after an update, or a case where the system appears to have crossed the boundaries of its approved use. What matters is that the organization has a way to capture that concern instead of letting it disappear into hallway conversation or individual frustration. For a beginner, issue management is one of the clearest signs that governance is real. People know where concerns go, how they are recorded, who reviews them, and how quickly they will be assessed. Without that structure, organizations often learn about serious weaknesses only after the same problem has repeated enough times to become painful, public, or much harder to correct. A strong issue control framework also depends on escalation paths and decision rights. Once a concern is logged, the organization needs to know whether it is a minor quality problem, a broader operational weakness, an emerging incident, or a sign that the deployment no longer matches the conditions under which it was originally approved. Different types of issues may require different responses, but confusion about who decides can itself become a governance failure. If staff notice a repeated problem but assume someone else owns it, the system may continue operating in a weakened state while uncertainty spreads across the teams around it. For a beginner, this is an important lesson because governance is not only about detecting issues. It is about making sure the organization can respond to them without delay, paralysis, or political avoidance. The deployment should never depend on people hoping somebody more senior will notice the problem eventually. There should be a known route from concern to review to action, with enough authority behind it to make the review meaningful. Issue controls also create organizational learning, which is one of their most important long-term benefits. When teams capture and review issues carefully, they begin to see patterns that might otherwise remain hidden. They may discover that certain kinds of data cause repeated trouble, that a specific workflow encourages over-reliance, that training was weaker than expected, or that an update introduced a new fragility into the system. Those patterns help the organization improve not only the current deployment, but also its future governance decisions. For a beginner, this matters because governance becomes stronger when issues are treated as evidence rather than embarrassment. A mature organization does not assume that surfacing problems means the project has failed. It assumes that ignoring the problems would be a much greater failure. By building issue controls into deployment, the organization creates a practical way to learn from live experience before weak signals turn into larger incidents, trust erosion, or preventable downstream harm. User training is the fourth pillar in this topic, and it is often the most underestimated. Many deployments fail not because the model is completely broken, but because the people around the model were never taught how to use it responsibly. A system may have clear limits, but users may not know them. Human oversight may be required, but reviewers may not understand what kinds of errors to watch for. Sensitive data may need special handling, but staff may assume the tool is safe for any input because it appears polished and officially approved. For a beginner, this is a crucial lesson. Governance controls do not work if the workforce does not understand them. Training is how the organization turns documented expectations into real behavior by giving users the context, caution, and confidence they need to work with the system without falling into either blind trust or total confusion. Good user training should be role-based and practical. The people maintaining the system need one kind of knowledge, managers supervising its use need another, and frontline users relying on its outputs need something else entirely. Training should explain what the system is meant to do, what it is not meant to do, what kinds of outputs deserve extra caution, what kinds of data should not be entered casually, how escalation works, and what to do when the system seems wrong or uncertain. For a beginner, the most important point is that training should not be treated as a one-time formality completed just before launch. If the system changes, if the workflow evolves, or if new issues appear after deployment, training should evolve too. Otherwise, the organization creates a dangerous gap between what governance documents say and what real users believe when they are under pressure, moving quickly, and tempted to accept polished outputs at face value. Training also plays a major role in controlling over-reliance, which is one of the most common operational dangers in AI deployment. When a system is fluent, fast, and consistently available, people may begin trusting it more than they should, especially if it saves time or appears more organized than their own thinking in a busy moment. That is why training must do more than explain features. It must teach skepticism, judgment, and appropriate challenge. Users should know that a confident output is not the same as a correct output, that the system may struggle in certain contexts, and that their role is not to bless the machine automatically, but to supervise it intelligently. For a beginner, this idea is foundational. Human oversight is only real when users are trained to exercise independent judgment. If training encourages speed without caution or confidence without challenge, the organization may believe it has governance in place while actually creating conditions where weak outputs move through the workflow with very little meaningful resistance. The strongest deployments treat data, risk, issue management, and user training as connected controls rather than separate programs. A data problem may create a new risk. A risk signal may surface through repeated user issues. An issue review may reveal a training gap. A training update may reduce future data misuse or improve escalation quality. When these elements are linked, the organization gains a much clearer picture of how the deployment is behaving and where its governance controls need to tighten. For a beginner, this connected view is essential because real deployments do not fail in neat categories. Problems travel across technical, operational, and human boundaries. A weak data source can become a misleading output, which becomes user over-reliance, which becomes an issue, which becomes a larger risk if the organization has no route for learning and response. Governance controls work best when they are built to reflect that reality instead of treating each part of the deployment as though it lives alone. A simple example can make this more concrete. Imagine an organization deploying an AI assistant to help internal staff respond to customer requests. Data controls would decide what customer information may enter the system, how access is limited, and how long interaction records are retained. Risk controls would define what kinds of errors matter most, who owns those risks, and what thresholds would trigger closer review or a pause in use. Issue controls would give staff a clear way to report weak or harmful outputs, confusing behavior, or patterns they begin to notice across cases. User training would teach employees when to trust the assistant as a draft aid, when to double-check its work, when sensitive topics require extra care, and how to escalate concerns instead of working around them quietly. For a beginner, this example shows that deployment governance is not a speech about responsibility. It is a system of practical controls that shapes how the tool is used every day and how the organization responds when real life turns out to be messier than the launch plan assumed. As we close, the main lesson is that applying governance controls at deployment means building a working system of discipline around the AI, not just approving the technology and hoping people behave wisely afterward. Data controls keep information flows proportionate, reliable, and governable. Risk controls make uncertainty visible, assign ownership, and connect warning signs to real decisions. Issue controls ensure that concerns from live use are captured, reviewed, escalated, and turned into action or learning. User training prepares the workforce to use the system with judgment instead of habit, speed, or blind trust. For a new learner, these 4 areas are some of the clearest signs that an organization is serious about responsible deployment. A mature AI program does not rely on capability alone. It builds operational controls strong enough to keep that capability within boundaries that remain understandable, accountable, and defensible once the system is no longer a project on paper, but a real force inside everyday work.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.